Here we have a hot bowl of soup is served at a dinner party. It starts cooling according to Newton's law of cooling, so that the temperature at time t, so the lowercase t is time, is given by this capital T. This is where T is measured in minutes and capital T is measured in degrees Fahrenheit. So kind of tricky when our variables are the same letters, but we're plugging in a lowercase t, and that's in minutes, and we're getting out a capital T, which is in degrees Fahrenheit. So tell me how long that the bowl of soup has been sitting, and I can tell you what temperature it's cooled down to be. So the first part says, what is the initial temperature of the soup at T equals 0 minutes? If this was of the form y equals c times a to the x, if it was that type of exponential, c would be given for us. It's not of that type where c is the initial value. It's a different form of an exponential function. That's okay. We're just going to plug in times 0 to this. Capital T of 0 is 60 plus 138 e to the negative 0.05 times 0. I can grab my calculator and just plug in to these values. We have 60 plus 138, and then we have e raised to the 0 is what it's going to be. So anything to the 0 is actually 1. So we're doing really 60 plus 138 times 1, or 60 plus 138 is 198. Remember, we plugged in 0 minutes, so we're getting out degrees Fahrenheit. We're learning how to work with and solve an exponential function in a word problem. Well, 100 degrees will be kind of a good temp for us to maybe start eating it. We want to figure out how long we're going to have to let it cool to get to that 100 degrees. So that is our capital T. We're going to solve for lowercase t, figure out how many minutes till we get to 100 degrees. It initially is 198 degrees Fahrenheit at time 0. How long are we going to have to let it sit? So we're going to solve this exponential function by isolating the exponential term on one side by itself, and then converting it to a log and solving for t on its own. So first step to isolate, I'm going to subtract 60 from both sides. I get 40 equals 138 times e to the negative 0.05t. So I still don't have the exponential term isolated. I have it multiplied by 138, so I'm going to divide both sides by 138. I'll plug this into my calculator and see if 40 divided by 138 can become a nice decimal. If it's something crazy that keeps going on forever, I'm just going to leave it as a fraction. So it is a crazy decimal. I'm going to leave it. I'm going to hit math enter enter on my calculator to reduce it. It's really just 20 over 69. Now I have e on one side by itself raised to a power of negative 0.05t. Now that I have isolated the exponential term, I'm going to convert it to a log. So this is base e, so I'm going to do ln of both sides. Ln of 20 over 69 equals ln of e to the negative 0.05t. That way the e and ln can cancel. So I'm going to be left with negative 0.05t when that cancels. Bring it up here. ln and e cancel. We have negative 0.05t equals that ln of 20 over 69. Last step after we isolate and then convert to a log is to solve for the variable. So my last step, I'm going to divide both sides by negative 0.05. That way I can get t all by itself. So I want to enter this one in my calculator just like this. I want to do ln of 20 divided by 69 and then close those parentheses and then divide that by negative 0.05. And we're going to just round to maybe one decimal place. It's going to take 24.8. And what is t in? It's in minutes. So the soup is starting off at almost 200 degrees Fahrenheit. It takes almost 25 minutes to cool it down to 100 degrees Fahrenheit.